let's now look at some gas volume questions, and we can use what we know from the other calculations to help us here. So we have a reaction between copper oxide and ammonia, and that produces copper, nitrogen and water. Now let's work out what the gases are here. So at 20 degrees Celsius, copper is in a solid, so we'll take that out. Copper oxide is that kind of black powder you might have used in National 5 chemistry, acids and alkalis. At 20 degrees that's a black powder. Copper is a metal at 20 degrees Celsius, and the water would be a liquid, so we'll take that out because we don't need that. That means that the two gases we're interested in are these two. So let's write these out. 2NH3 going to N2, and then this is what we produce. So this is 2 moles to 1 mole. If this is 100 centimeters cubed, we can use the fact that all gases have the same molar volume, i.e. 24 litres per mole of gas at about 20 degrees Celsius, then that means that we can actually use that to, it doesn't matter which gas it is, we can use these ratios to help us by comparison. So if I've got 2 moles and that's 100 centimetres cubed, then that means 1 mole of nitrogen must be half that volume, which is going to be 50 centimetres cubed. So these are called reacting volumes. Now your ammonia is used up in that reaction because the copper oxide is in excess, which means all the ammonia has to be used. So that means all you're left with is 50 centimetres cubed. The answer is A. Let's try another one. We've got 100 centimetres cubed of propane, and that's mixed with 600 centimetres cubed of oxygen, and then that mixture is ignited. Notice that the water is a liquid, so we don't really include that. Let's write out the equation again, and then we'll put our mole ratios in, we'll put our volume ratios in for the things that are going to have volume, and let's find out what the volumes would be. So it's going to be C3H8 plus 5O2 gives us 3CO2 plus 4H2O. And because the water is a liquid, I'm going to score that out. That means that we have 1 mole reacting with 5 moles, and that produces 3 moles of gas. Therefore, if we start with the question says that there's 100 centimetres cubed of propane mixed with 600 centimetres of oxygen, let's work out what we need to be able to react. That means 1 centimetre cubed. That means for the mole ratio then is going to be for every 1 mole, that's going to react with 100 centimetres cubed. That means we're going to have 500 centimetres cubed needed to react with oxygen. I know it said 600, I'm going to come back to that in a second. And that would then produce 300 centimetres cubed of gas. Now, we've used up 500 of the oxygen, but there was 100 left over because it was 600 that you used. That means your reacting gas, or your resulting gas mixture, must be 300 centimetres cubed of carbon dioxide and 100 centimetres cubed unreacted O2. That means in total you've produced, or you've got 400 centimetres cubed in that reaction, which means it's B. I'll pause there just to let you check anything.